Hi y'all, in this video we're going to talk about section 5.4, which is theorems about definite integrals. So if you look at rules number 1 and number 2, they should be hopefully fairly obvious to you. If you have an integral from some a to some b of a function plus or minus another function, you can actually split that into two integrals. So you can have the function of f of x dx, that integral, plus or minus the integral of g of x dx. So you can break up an integral over addition. In rule 2, if you have a constant in front of a function being multiplied by the function, you can actually pull the constant in front of the integral symbol. So you can pull the constant outside of the integral. You can only do that with constants. So we can use these rules to find some values of integrals without actually punching them in our calculator. So if you look at example A, they want us to find the integral from 0 to 2 of 2x plus x squared. Well, we know that the 2x by itself is 4, and we know that the x squared by itself is 2.6 repeating. So if we break this integral up into two separate integrals, we're really just taking the value of the integral of the 2x, which was 4, and we're adding the value of the integral of the x squared, which was 2.6 repeating. And so you would get 6.6 repeating. You can check that in the calculator if you want. Same thing with b. We can split this up over 2, and now we're doing a subtraction. So we would do 4 minus 2.6 repeating, which would be 1.3 repeating. And again, you could check that in the calculator. So for the u-tries, let me just set you up with the first one. Because 8/3 is a constant, you can pull that outside of the integral. So you're doing 8/3 times the integral of 2x dx. So take a minute, try C and D, pause the video. When you're done, unpause the video and check your answers. Okay, so you should have gotten 32 over 3 for C, and for D, you should have gotten 40. Okay, the next rule deals with taking an integral from one value, a, to the same value, a. So basically, if you think about this on a curve, if you have some curve f of x, if you're just doing from a to a, you're not actually going to have any area under the curve. That's just a straight line. There is no area there, so that value has to be 0. So if you take any integral from a to a, no matter what number a is, that integral will always be 0 because there is no area. Rule number 4 is talking about reversing the order. So it's talking about working backwards. It's saying start with b and work backwards to a. That would give you the negative value of the integral. So that is equal to negative a to b f of x. Working backwards changes the sign of the integral. So in example 2, you see we have an integral from 0 to 2 of 2x dx is equal to 4. So if we flip a and b, that's going to make it equal to negative 4. Okay, and number 5, rule number 5, deals with combining two integrals together. So we're going from a to c and from c to b. So if we have the same number on the top of one integral and on the bottom of another integral, that's really just taking the area from a to b of f of x dx. So the starting value and the ending value. So let's think about it this way. Suppose c is in between a and b. This is kind of the obvious one. So let's say we have some function, doesn't matter what it looks like. If I take the area from a to c, and I add to that the area from a to b, or from c to b, sorry, clearly, all together, that makes the area from a to b. So a to c plus c to b makes the total area a to b. And I think that's pretty obvious. But what happens if c is not in between a and b? Let's suppose that c is greater than b. Does this theorem still hold true? And it wouldn't matter if c was less than. We could also do it that way. So if we take the area from a to c, that's this entire area, and we add to that the area from c to b, we're actually working backwards now. So that's actually going to be a negative value. So if we add c to b, f of x dx, because we're working backwards, that's really negative b to c, because the order should be b to c, f of x dx. So we're really taking the area from a to c and we're subtracting the area from b to c. When we do that, we're left with the area from a to b. So that still is equal to a to b f of x dx. So it doesn't matter where the c value falls. If it's in between a and b or outside of them, you will still get that same result. So in example 3, they're giving us the line 2x, y equals 2x, and they're telling us from 0 to 4 the entire area is 16. So we know that this entire area under the curve is 16. And it says that the area from 0 to 3, so if we just chop it off at 3, that this area right here is 9. Okay, so let's think about this with numbers. We want to find the integral from 3 to 4. And that would be from 2x dx. So this should be really fairly obvious. If the entire integral is 16, and we know that part of it is 9, then the missing part is going to be 16 minus 9, which is 7. So the integral from 3 to 4 should be 7, because 9 plus 7 adds up to 16. Okay, so now let's talk about even functions. Even functions, if you remember, are functions that are symmetric over the y-axis. A real easy one to think about is y equals x squared. That's an even function. If you fold it over the y-axis, you would get this, it would match up to itself. So an even function, if you take the integral, let's say from to positive a to negative a, if you take these areas on either side, where a is really the same number, just positive and negative, these two areas should be equal to each other. So if you take an integral from negative a to 0 of an even function, that should be equal to the area from 0 to a of the even function. And so the whole area, negative a to positive a, is 2 times one of those areas. So if I went from 0 to a, or I could go from negative a to 0. So if we look at example 4, from 0 to 2 of x squared dx, that's going to be the same thing as going from negative 2 to 0 of x squared dx. It's also half of going from negative 2 to positive 2, because the 0 is half of the total area. And so we saw back on the previous page in example 1 that 0 to 2 x squared dx was 2.6 repeating. So this would also be 2.6 repeating, and this would also be 2.6 repeating. And you can check in your calculator. So odd functions are symmetric over the line y equals x. And a really easy odd function to think about is a cubic, y equals x cubed. And so with an odd function, if you take the area from negative a to positive a, these integrals are actually going to cancel each other out, because they're going to be the same value, but one's going to be positive and one's going to be negative. So if you take the area from negative a to positive a of an odd function, that integral has to equal 0, because we have a positive area and a negative area of the same value, so they're going to cancel each other out. So in example 5, that has to be 0. Okay, in example 6, they're giving us 4 different integrals. Notice they're not giving us any y values. So we don't know what those functions are, so the calculator is going to be useless to us, so we can't use those. So what we got to do is use our rules. So in a, it wants the integral of f plus g. So break that up into 2 separate integrals. You know that the integral of f is 4, and you know that the integral of g is 1. So altogether, that has to be 5. In b, we've got a constant right here in front of the function. Pull the constant out. Put it in front of the integral. So we know that the integral of g of x dx is 1, because they told us that. So this is just c times 1. So this is just c. So in part C, it's a little more complicated. We're going to have to break this up into two different integrals, and we're also going to have to pull the constants out. So we're going to pull the 5 out. I'm going to pull the 2 out. And notice this is f of x squared dx. Okay, so g of x, again, the value was 1, so I have 5 times 1, minus 2 times, now the f of x squared is the one that's a value of 8. I am not squaring any of the numbers given to me. This just says the integral of f of x squared is 8, so I'm only plugging in 8. Do not square anything. So this would give me 5 minus 16, which would give me negative 11, okay? All right, I want you to try the next 3. Pause the video. When you're done, unpause, check your answers. Okay, so I'm sorry, F was not a you try. So we're going to do F together because we didn't talk about what to do with a plus constant here on the end. So we're going to break this up into 2 separate integrals. And then I have to pull the 2 out front of the g of x. So this is going to be plus the integral from a to b of 4 dx. Okay, so we know that g dx, that's just 1 again. And so we're doing an integral from a to b of 4 dx. 4 is a function. That's a value. We can put that in the calculator. So let's put the integral with the 4 into the calculator. So we want to go to Menu, Calculus, Integral. We're going to go from a to b. That's okay. We can do that in our CAS. You cannot do that in a regular Inspire. Put a 4 and then just put an x on the end. So the integral from a to b of 4 dx is negative 4 a minus b. So this becomes 2 minus 4 times a minus b. Okay, let's look at example 7. The average value of a function equals 4 from 1 to 6 and equals 5 from 6 to 8. What is the average value of the function from 1 to 8? So if you remember, average value is 1 over b minus a times the integral. So it's telling us the average value equals 4 if you go from 1 to 6. Oh, I left off the fraction. 1 over 6 minus 1 from 1 to 6 of the function v of x, d of x. And it equals 5 from 8 to 6. So it would be 8 minus 6 from 6 to 8, v of x dx. So what we want to do is we want to get the integral parts by themselves. So in this case, we're going to multiply each side by 5 because this would be 1 over 5. So if I multiply by 5, I end up with 20 equals the integral from 1 to 6 v of x dx. Over here, this is really just the fraction 1/2, so I'm going to multiply both sides by 2. So 10 is going to be equal to the integral from 6 to 8 of v of x dx. So it wants us to find the value from 1 to 8. So 1 to 8 could be broken up. I could break it up from 1 to 6 and then do from 6 to 8. And so I know 1 to 6 is 20, and I know 6 to 8 is 10. So altogether, the integral has to be 30. And then it wants the average value from 1 to 8. So then I'm going to take 1 over 8 minus 1 times the integral from 1 to 8, v of x dx. And so the average value is 1/7 times 30, which you can just leave as 30 over 7. All right, if you're trying to find the area between two curves, the first thing you want to do is graph these curves in your calculator. So I'm going to do negative x squared plus 4x minus 1. And then I have x squared minus 4x plus 5. So the reason I want to graph these is I want to see where they intersect. So here's my first one. This is f of x. And then my second curve is g of x. And so I need to know where do these curves intersect because I'm trying to find this area right here. So I need my 2 intersection points. I can get that from the calculator. If you go to Menu, Geometry, Points and Lines, Intersection Points, click on both curves. The calculator will find them for you. Okay, so I have both of my curves. If you can't read your points, you can move them around, but I can see that I intersect at 1 and 3. And so then what I want to do is I want to set up an integral from between the 2 intersection points with the lowest one at the bottom and the highest one at the top. And I want to do the top curve minus the bottom curve. So f of x is the top curve, and g of x is the bottom curve. So I'm going to subtract g of x dx. And I'm just going to type that in my calculator and solve this integral using my calculator. So Menu, Calculus, Integral. I'm going from 1 to 3. I have f of x, which is negative x squared plus 4x minus 1. And then I'm subtracting g of x. So do a minus and then do a parentheses and then put your g of x in. X squared minus 4x plus 5. Dx on the end. And I get 8/3. So the area between these 2 curves is 8/3. So in general, when you're solving an integral, you're always going to take the integral of the top curve minus the bottom curve. And you can actually separate that into 2 separate integrals if you want. I usually tend to do it in one integral. It doesn't matter. Either way, you'll get the same answer. So I'm going to have you try the next one, example 9. Give this one a try. When you're done, pause the video. When you're done, check your answer. Okay, so for this one, you should have gotten 5.208. All right, in example 10, we want to find the area between sine x and 1/2 x. So let's graph both of those. So I have sine x, and then I have 1/2 x. Okay, so I have actually 3 intersection points if you look. So sine x goes like this. 1/2 x goes like this. Should have continued back my sine x. So I'm intersecting in 3 places. I'm intersecting at 0, I'm intersecting at negative 1.9, and at positive 1.9. So I'm actually going to have to do this twice. I have 2 separate areas I have to deal with, okay? So I'm going to start with this first area. I would do it from negative 1.9 to positive 0. And I'm going to do top curve minus bottom curve. Here, the 1/2 x is the top curve. And the bottom curve is the sine x. And I'm not going to type this in the calculator, but if you type this in, actually I'm not going to type this in the calculator yet. I'm going to do plus, and now I'm going to do the second area. So the second area goes from 0 to 1.9. Now the top curve is sine x. And the bottom curve is the 1/2 x. And you can type this entire thing in the calculator exactly like it looks, and you should get 8.42. So bring your questions to class, and we'll see you next time.